Hi, so this is the exam review for exam 1. I'm going to have a short explanation on the significant figures, and I have some examples on the things we've covered in the lecture. Some of them are just memorizing, so you have to memorize it. Some of them needs practice solving them, so I have some examples here. So one of the things that you have to know is counting the significant figures. So when you see a number, basically it's like you have it's nothing beside these two. It's either a number, a non-zero number digit, or it's zero. Okay, so if it's a non-zero digit, non-zero digit, is it a significant figure? Yes. If it's zero, then it's in these three categories. It's either leading zero. Are leading zero significant figure? No, they're not. Leading zero like what? Like the zeros that comes before a non-zero digit. 2, 3, 4. These are the leading zeros, and they're not significant figure. If it's sandwich zero, it is significant figure like 3, 0, 4, the zero between two non-zero digits. If it's trailing zero, it depends. If you have decimal place like 100.0. So if you have a decimal, all the trailing zero counted as significant figure. So you count these, and also you have 1, so you have 5 sig fig. Okay. If no decimal place, decimal. So if you have decimal, yes. If no decimal, no. Let's do the check here. Okay. Yes and no. So like for example 2300, you have two zeros, no decimal place, so you do not count them as significant figure, therefore it has two significant figure. Okay, so this is basically the summary. If it's a non-zero, it is significant figure. If it's zero, it falls into these three categories: leading zeros, no; sandwich zeros, yes; and trailing zero, it depends on the decimal place. So let's see if we can find the significant figures of these numbers. So the first one, all non-zero digits, so you have 3 sig figs. Second one, you have 1, 2, 3, 4, 5. You count this because it's a sandwich zero, so it has 5 sig figs. This one has both sandwich zero and trailing zeros. There is no decimal place, so we do not count these. So we have 1, 2, 3, and 4, so it's 4 sig figs. And this one we have leading zero and trailing zero. We have a decimal place here, therefore we count the trailing zeros, but we do not count the leading zeros. So it's 1, 2, 3, 4. It's 4 sig figs. We have trailing zero and decimal place, so we count them 1, 2, 3, 4. So we have 4 sig fig. Here we have trailing zeros, no decimal point, so we do not count them 1, 2. So just 2 sig fig. Okay. So that's how we count the significant figures. What do we do in the process? So if you have multi-step calculation, the first thing is you never round it before the last step. So, and you have to remember PEMDAS, order of operation, parentheses, exponents, exponential, multiplication, division, and then addition, subtraction. So if you have a ratio, first you put the parentheses, and you have to do whatever inside the parentheses. Okay, so let's do that. So 3.49 plus decimal place under decimal place, and it's 32. There's nothing after decimal place, so it's 2 and 3, and that's addition. So it's 9, 4, decimal place, 5, and 3. Okay. So what is the last significant figure? So we do round it. We do, well, yes, if it's just a single step, we have to round it from here, because the addition says the smallest number of decimal places. So this one has 0 decimal place, so the final answer should have 0 decimal place. So this is the final significant figure. But do we round it? No, not yet. So if you have multi-step, you do not round until the last step, but you underline the last significant figure so that you know how many sig figs you have. And for the denominator, if you put these numbers in your calculator, you will get 1.6606. Always write 4 decimal places. And what is the last sig fig? So it's a multiplication. We know that it goes with the smallest number of significant figure. This one has 2 sig figs. This one has 3. So the answer should has 2. So it's 1 and 2. I do not round it. I just underline the last significant figure so I can use it in the final answer. So if you divide these two numbers, and I'm doing it right now, 1.6609, you will get 21.3679. Always 4 decimal places, and then you have to go back and see how many significant figures you have to report in. So in the top, how many significant figures do I have? I write 4, but I have 2. That's why we underline the last one. The same thing for the bottom one. I write 5 here, but I know I have 2 significant figures, so the final answer should have also 2 significant figures. So we cut it from here. Therefore, it's 21. That's the final answer. Okay. So the next one, PEMDAS, we have to do whatever we have inside the parentheses. So the first one is 4.23 times 1, okay? So the answer is the same thing, but it's a multiplication. We have 2 sig figs here and 3 sig figs here, so the answer should have 2 sig figs. So this one is the last significant figure in this, the first one. And multiply the next parenthesis. So it's a reduction. So we have 2.545 decimal place, 0074, and that's 0. Okay, so we have to put 2 zeros to do the reduction. This is 4, this is 9, and this one is 10. So it's 6, 2, 4, 4, decimal place 2. And you have to cut it from the smallest decimal place. And I know this is my last significant figure, but I do not round it. So I keep writing with red. So then the second parenthesis is 2.4426. I write the whole thing. I do not round it. I underline the last significant figure. So it's a multiplication. Here, how many sig figs do I have? I have 2. Here I have 3. So the answer should have 2 sig figs. And if you multiply those two, you get 10.3322. You have 2 significant figures, so it's 1, 2. So you have to be careful. If you write 10, how many sig figs do you have? You have only 1, right? Because it's a trailing 0 without a decimal place. So you have to put a decimal place here to make it 2 significant figures. Okay. The last one, so you have 100 times this, so it is, let me write with a different color so it doesn't be mixed up with the one at the top. So if you multiply those two, it's 2.39. okay? But how many sig figs? So 100 have one sig fig, right? Because the two trailing zero, there is no decimal place. So it's one sig fig there and three sig figs here. So the answer should have one sig fig. So this is the last significant figure, 2. And if you subtract these, so 30.934, decimal place, well, it doesn't have any decimal place, so 8 is here, okay? And that's subtraction, so it's 4, 3, 9, that's 2 and 10, decimal place 2, 2, so it's 22.934. What is the last significant figure? So we say smallest number of decimal places, so we have to draw a line here. So therefore this is the last significant figure, okay? So 2 is the last significant figure. And how many sig figs do we have here? We have one significant figure here and two significant figures here. So we do not round it, we do the division, and the answer will be 0.1042. And 1 and 2, the division says smallest number of sig figs, so it should be one sig fig. So starting from here, 0 is not counted, so 1 is the sig fig, so we have to cut it from here. Therefore the answer is 0.1. Okay, I hope this would fix everything. I mean, the rest of them is just the same thing. You have to, don't forget to do not round, not to round until the last step. Underline the last significant figure so that you know how many sig figs you have in your answer. And don't forget the rule for addition, subtraction, it's the smallest number of decimal place. For division, multiplication, smallest number of sig figs, okay? So next question is dimensional analysis. For dimensional analysis, for all the questions, first you have to write down the given information, okay? So what is the volume of an element with a mass? So we have the mass. It's 453 gram. Don't forget the unit. If the density, so we have the density. The density is 8.32 times 10 to 5 milligram per cubic inch. Okay, so these are given. What is wanted? The wanted is the volume in what unit? In cubic inches. Okay, so what do we need to convert? We need to convert, we have cubic inch, we have gram and milligram, so we have to convert gram to milligram. What do we know about this conversion? We know that 1 milligram is 10 to negative 3 gram, okay? So always start with the given information. Well, we have 2 given, but we know that the unit, which is in ratio, can be used as a conversion factor. So we start with a given that has the 1 unit. I mean the unit like this, like gram. We start with the mass. So from here, I cannot use gram. I have to go to milligram, so I can use this density. So that's the first step. I have to put gram here, so I can cancel it with that one. So gram to milligram. And from our equality, I know that 10 to negative 3 gram is 1 milligram, okay? So next step, convert, because what we want is cubic inch, okay? What we have is milligram so far, so I have to go from milligram to cubic inch. So I have the milligram on top, so I have to put it on bottom to cancel it and have cubic inch here, okay? So the density says this number of milligram is in 1 cubic inch, okay? That's the definition of the density and definition of the unit, okay? So that's how I'm going to write it. So 8.32 times 10 to 5 is 1 cubic inch. Okay, does that make sense? I'm saying it again. The density is the mass over the volume. when we say the density is this number, it means it's 8.32 times 10 to 5 milligram in each cubic inch, okay? And that's true for all the units which are in ratio, okay? It means that number with the top unit is in one of the bottom units, okay? So when I'm trying to get rid of the milligram, I should know that this number refers to the milligram, not the cubic inch, okay? So if I write it like this, for example, 8.32 times 10 to 5 cubic inch to milligram, that would give you a wrong answer, okay? Because this number milligram is in 1 cubic inch. You have to be careful with this, okay? So let me erase this. Okay. Okay. So we can cancel gram with gram, milligram with milligram, and we end up with cubic inch, and that's what we want. Okay, so when you're good with the unit, the rest is just putting these numbers in a calculator, and the number is 5.44 times 10 to negative 3 cubic inches. Okay, so let's go to the next question. A car is driving at 75 mile per hour. I want to write mile per hour like this. It's the same thing, right? Mile per hour. 75 miles in 1 hour. How long does it take for a car to travel 10.4 kilometer? So I have 10.4 kilometers as, so this is the rate or this velocity. I write with R, and X as distance. So, and the unit is kilometer. And that's given. So what is wanted? Wanted is, it says how long in minutes. So we want time in minutes. What do we need to convert? Well, we need to convert kilometer to miles, and we also need to convert hour to minutes. Okay, so what do we know about this conversion? We know that 1 mile is 1.609 kilometer, and 1 hour is 60 minutes. Okay, so we start with the given information. We start with this. So 10.4 kilometer times, we have to go to from kilometer to miles. Okay, so I put kilometer here and mile on top, and from the equality here I know that 1 mile is 1.69009. Okay, so from mile, I have it on top, I have to cancel it, so I put it on here. From mile I want to go to time zone, so it's H here, so I know, so I have to put H here, and 75 miles is 1 hour, so 75 mile is 1 hour. Again, the same thing like the density. If you have a ratio unit, it means whatever you have, the number is for the top unit, yeah, and it's per one the bottom unit. Okay, so that's it. We have an hour. We want the answer in minutes, so 1 hour is 60 minutes. And again, I put hour here, so I have to put it on the bottom to get rid of that. Okay, so kilometer with kilometer, miles with miles, hour with hour, and we end up with minutes. And that's what we want. Okay, here. So the rest is just putting these numbers in the calculator, and you will get 5.17 minutes. Okay, so what is this? So I think that's the last dimensional analysis question. An electromagnetic radiation has a wavelength of 730 nanometer. So if you read a question and you don't know the concept of the question, it's still okay. Just write down the information. You see, maybe you don't know about electromagnetic radiation and you don't know about wavelength, but the question is not asking you to explain these things. It's just a conversion, okay? So you have a number in nanometer, and it's asking that number in micrometer, okay? So you have nanometer to micrometer conversion. I didn't write the list like given, wanted, convert to make it shorter, okay? So what do we know about this conversion? I know that 1 nanometer is 10 to negative 9 meter, okay? I want to remind you this again. Always 1 goes with the prefix, and the definition of the prefix, which is 10 to minus 9, goes with the base units. Okay, so 1 nanometer is 10 to negative 9 meter. Do not mix it up with 10 to negative 9 nanometer is 1 meter. Always 1 goes with a prefix, and the definition of the prefix, which is 10 to negative 9, goes with the base unit. Okay. Also, I know that 1 micrometer is 10 to negative 6 meter. Okay. So to convert that, we have 730 nanometer. So we want to convert it. I want to get rid of nanometer, so I have to put it on the bottom. And from the equality, I can go from nanometer to meter, and 1 nanometer is 10 to negative 9 meter. And then from meter, I want to go to micrometer because that's what I want to end up with. So I put meter on the bottom to get rid of that with the other meter, and then micrometer on here, and 1 micrometer is 10 to negative 6. Okay, and if you remember this from scientific notation, when we have to we can deal with 10 to the powers. If you take this to the top, it's 10 to positive 6 now. So if you add these two, it's, I didn't write it here, so it's the same number, and I have these two, so negative 9 and 6, so it's, if you add them, it's negative 3. Okay, and what's the unit? Micrometer, or you can say 0.73 micrometer. Okay, so question number 8, finding the number of electrons, protons, and neutrons. Okay, we talked about atomic number and mass number. So the number you can see here is mass number, and mass number is proton plus neutron. Okay, the atomic number, you might be given the atomic number, or like this question, you don't have the atomic number, but you can always find the atomic number from the periodic table. So if you check zinc on the periodic table, you would see that the atomic number is 30. Okay, so atomic number always tells you how many protons you have. So number of protons is the atomic number, is 30. Electrons, you have to check the charge. Okay, if it has a positive charge, it means it have more protons, because proton is positive. So if you have positive charge, it means you have more proton, and you have 2 positive charge, it means you have 2 more protons. So the electrons should be 2 less than the protons. So it's 30, therefore you should have 28 electrons. Okay, neutrons, this number, the atomic mass, is the sum of protons and neutrons. So 63 minus the number of protons, which is 30, is number of neutrons, which is 33. Okay, Okay, next one, Mn, you check the periodic table, and the atomic number is 25. Therefore, number of protons is 25. Number of electrons is positive, so it should have more protons and less electron. And it's 4 positive, so it's 4 less electron. So it's 21. Because this is 25, it should have 21 electron. Neutron, again, the atomic number is 41. So if you subtract those two, you have 16 neutrons. Same thing, you check the atomic number for iodine, it's 53. Therefore, proton, you have 53 proton. Electron, it's -1 charge, so it means it's negatively charged. Therefore, it has more electron because electron charge is negative, okay? And it's 1 negative, so it has 1 more electron than protons. So it's 53 here, so it should have 54 electron. And neutron, we have 79, so 79 minus 53, which is the number of proton, gives you the number of neutron, which is 26. Okay, P, phosphorus, atomic number is 15. P, we have 15 proton. It's a 3 negative charge, so it means it has more electron and 3 more electron, so therefore it has 18 electron. And neutron is subtracting those two, so it has 13 electron. Gallium, atomic number in the periodic table, check it, is 31, so it has 31 proton. It's positively charged, so it has more proton, and it's 3 plus, so it has 3 more protons or 3 less electron. So it has 31 protons, so it should have 28 electron. And neutron is a subtraction of these two, so it's 35 neutron. The sum of proton and neutron is 66, and it is 31 protons, so we should have 35 neutron. And selenium, the atomic number is 34, so it has 34 proton. It's negatively charged, so it should have more electron, and it's 2 negative, so 2 more, so it's 36. And neutron is the difference between atomic number and mass number, so it's 32. Okay, the common mistake in this kind of question is when you want to write the number of neutron, you look at this number and you just immediately write 66 neutron, which is wrong. Okay, number of neutron is a subtraction of atomic number from the mass number, gives you the number of neutron. Okay, next question is about average atomic mass. There should be only 2 types of this question that you had it in the recitation worksheet of that week. Okay, so and there are only 2 formulas that you can use for this kind of question. It's not either, you have to use both of them. So it's m1x1 plus m2x2. Okay, this is one of them, and the other one is x1 plus x2 equal 1. Okay, you have to use these two to solve the problem. Okay, so first let's write down the given information. So vanadium has 2 isotopes. The mass of the isotope is, so the first isotope M1 is 49.9472, and so let me check the answers. M2 is 50.9440. Okay, so we have this, we need the average mass too. So we're talking about vanadium. You can check the periodic table and you can find the average mass as 50.9415 U. Oops, not micron, U. Okay, so when you have two atomic mass and you want to find both natural abundance, you have to do this. So x1 is 1 minus x2, and then you plug this into here. Okay, if you have one of the natural abundances and one of the mass, so you can find the other natural abundance by this. So you can find it, and then you plug the number inside this. So you have one equation, one unknown. You can solve it. If you have the masses, you have to do this and then plug this x1 into the equation and solve it. How do we do that? Do this. So let me write it here. Yeah, and let's change the color. Okay, so we know the average mass. So let's write the average mass: 50.49415 equal. We know the m1. M1 is 49.9472. Instead of x1, I write this. So instead of x1, I write 1 minus x2. That's the same thing, right? They're equal. Plus, we have m2. So m2 is 50.9440 times x2. So now we have one equation with one unknown, right? So it's just x2. So we can solve this. The first step you need to do, you have to expand this, distribute this number into both of them, okay? So I just write this again, 50.9415. So this times 1 is itself, minus this times 1, x2 is this number times x2, 72x2, and I just write the rest of it, plus 50.9440x2. Okay, so I keep changing the color so it helps it to read. So I have a number here and a number here, so I can subtract 49.9472, and the same here, minus 49.9472. I can do it on both sides of the equal, right? So this goes with this one, and then for these two, I have 0.9943 equal. Also on here, I have x2 and x2, right? So I can just write it like this. So 50, because this one is a plus and this one is negative, I write this one first. 50.9440 minus 499472 times x2. See, I have this times x2 and this times x2, so I write the x2 here so I can add these two together. Okay, and the answer to that is let me see, it's 0.9968. Okay, 68 x2, and here I have 9943. So if you divide both of them by 9968, 9968, so we can cancel these two, and therefore x2 is, when you divide those two numbers, x2 is 0.9968 0.75, or if you write it in the percentage, it's 99.75%. Okay, and x1, so x1 is 1 minus x2. We got it from here. Okay, so x1 is 1 minus x2, so 1 minus 0.9975 is 0.0025. Or if you want it in a percent form, so you just move the decimal place 2 digits, right? So it's 0.25%. Okay, so that's it. All the questions just like that. You have to use these two equations. If you have one of the natural abundance, you find the other one and plug it in here. If you don't have any of them, you just write it based on the other one and then plug the whole sentence into the first equation. Okay, the last question is writing the formula and writing the name of the compound. Okay, so the first one we have name of the compound. So first you have to see if it's an ionic compound or a molecular compound, okay, if it makes ions. So you have to memorize the table of polyatomic ions, and this was one of the polyatomic ions is hydroxide, so therefore this is an ionic compound. To name the ionic compound, you write the name of the first ion, which is the cation that we have, calcium. So the name is calcium, and then the name of the ion, the next ion, which is hydroxide. So it's calcium hydroxide. Next one, it's Ki. Again, potassium is an ion, and iodine is potassium is a metal, and iodine is a non-metal. So metal with non-metal makes ionic compound. So therefore, it's an ionic compound. How to name it? Write the name of the first ion. You know, metals, the element or ion have the same name. So potassium is potassium. It's potassium ion. Potassium, and the ion of the nonmetal, you just have to add IDE to the end, and its iodine become iodide. So potassium iodide. Next one, we have sulfur and oxygen. You know, both of them are nonmetals, so therefore this is a molecular compound. That's the first step. You have to figure out if it's a molecular compound or ionic compound, because the rules are different. So for molecular compound, you have to use the prefixes and write the first one as a name of the element and the second one as the ion, like adding IDE to the end. Okay, so it's sulfur. And you have to be careful with the dictation spelling, because it's going to count off. Sulfur, and we have 2 oxygens, so it's dioxide. Next, nitrogen and oxygen, both of them nonmetals, so it's a molecular compound. So you just use the prefix and write the element. So it's di, you have 2 nitrogen, so it's dinitrogen. The first one, you just write the name of the element. The second one, you add IDE. Dinitrogen, we have 5 oxygens, so it's and you remember about the thing, we drop the A, then we have oxide, so I don't write A here, instead I write oxide, pentoxide. So next one, is it molecular or ionic? So if you remember, NH4 was one of the polyatomic ions. It's called ammonium. Okay, so if you have ion, therefore it's an ionic compound. So you write the name of the ion, ammonium chloride. You write the name of the ion, the second one, and add IDE. Okay, what's the next one? This one might be a little bit tricky. You see, it's hydrogen and oxygen. Both of them are nonmetals, but O2 with a -2 charge, it's peroxide. And H2O2, something that you should memorize. I mean, you will remember it because it's simple. H2O is water. H2O2 is peroxide. Okay, so the polyatomic ions. One of them was peroxide. So if you have O2 2 minus, it's a peroxide. You have to remember that. So we have hydrogen and peroxide. So it's hydrogen peroxide. And the last one is a molecular or ionic. You have chlorine and fluorine, both of them nonmetal, so it's molecular. So therefore you write the first element as chlorine, and you use the prefix. You have 3 of that, so it's trifluoride. Okay, and the last one, write the formula for these. So this is simpler because you have, the only thing is about the ions, you have to memorize the charges, so you could be able to write the right formula. So the first one is dinitrogen monoxide. It's easy. Molecular compound is easy. It just tells you how many of each you have. So dinitrogen monoxide. So it's it's N nitrogen and N2, sorry, dinitrogen, N2O, monoxide, 1 oxygen. Okay. Iron 2 dihydrogen phosphate. Dihydrogen phosphate is one of the polyatomic ions that you have to memorize. Okay. So dihydrogen phosphate, and you have to memorize that the charge is -1 because phosphate is -3. You add 2H plus to it, so you reduce the charge to -1. Okay, so that's the dihydrogen phosphate with -1. Always for ionic compound, write with the charges, and then when you make the compound, you can erase it. And it's iron 2, so Fe2 plus. Okay, so you do the crisscross, this goes there and this goes there, and then you have polyatomic ion. These 2 goes for the whole thing, so you have to put the polyatomic ion in parentheses. So it's Fe, you put the parentheses, H2PO4 2. Okay, so that's iron 2 dihydrogen phosphate. Okay, next one, ammonium hydroxide. Both of them are polyatomic ions. So you write the ion first, so with the charges. Hydroxide is OH minus, it's 1 and 1, so it's already charge balance. So you just write them next to each other. So let me just erase the charges. That's it. And maybe it's better to write OH more close to NH4. So that's ammonium hydroxide. Bromine pentafluoride is easy, molecular one. Bromine is bromine, Br. Penta means 5, so F5. Calcium sulfate, it's ionic. Sulfate is one of the polyatomic ions. So calcium is always 2 plus, it's in group 2. And sulfate, something that you have to memorize, is 2 minus. So 2 plus and 2 minus is balanced, so we just write them next to each other. So then you can erase the charge. That's calcium sulfate. Next one, carbon disulfide. Sulfide is S, okay, and it's a molecular because we have this prefix, so it's carbon disulfide, okay, CS2. And the last one, sodium oxide. Sodium is a metal, and oxygen is a non-metal, so it's ionic. So you have to write the ion with the charge. Oxide is O with 2 minus. Okay, so you do the crisscross, Therefore 2 goes there and 1 goes here. So it's Na2O. That's sodium oxide. Okay, so for both sides, I mean, if you have a formula, you have to name it, or you have the name, you have to write the formula. If you have the formula, just double check if it's a ionic compound or a molecular compound, then follow the rules for each of those. For the name, if you have, well, for the molecular, it's easy. You just see the prefix, write the number, and that's easy. For the ionic names, write it with charge first, and then do the crisscross. And if it's not the smallest ratio, reduce it to the smallest whole number ratio, and then just erase the charges, and that's it. Okay, that's the end of the exam review. If you have any question, you can come to my office hour and ask a question before the exam.